Sorry. My husband needed something. I don't know. Anyways, so going from left to right, we get smaller, faster. It's called an asymptote, where we're kind of just riding along the x-axis. So that's what I think. I always say it butts up against the x-axis, and it's called an asymptote. Okay, for it to decay, m is going to be between 0 and 1. So it's not going to be negative. If you can think about what happens when it's 0, and you can think about what happens if a multiplier is negative. You can also check in with me if you, it will not be equal to. You can check in with me if you're more curious, but for our purposes, it's between 0 and 1. It is not equal to, so it should not have that line underneath. Well, what does that mean for m? Well, instead of doubling, if we want to cut it in half, we would say 0.05. A fraction might be 3/4. And then if we think about growth and decay, like rates, maybe we subtract 5%. So then m ultimately is, 0.95, which is less than 1. All right, the examples on the first one that you see will look a lot like one of these 3 examples. So all they're asking you for that first exercise or practice set is growth or decay. So all you care about is the m. That's all you need to locate. And m is always tied to the unknown, or to the x, or the t in some of the cases. So I'm just going to take my pink pen and I'm going to highlight it. This is the one that's next to it. And this one. So, is this greater than 1? Yes, this is growth. Woohoo! This is less than 1. So sometimes they'll give you the 2 options. So from left to right, this is growing, and from left to right, this is decay. So this is your growth, and this is decay. This is between 0 and 1. It's 2/3. So if you think of one whole pizza, right, we're separating it into 3 parts, and it's just 2 of it. So it's not the whole pizza, and it's definitely not bigger than a pizza. So it's decay. So we're going to select B. This one, 7/4 is bigger than 1. So again, 4/4 is 1. So if our numerator, it's like having 2 pizzas. Ooh, numb. We had some pizza on Friday night. So this one is all done. There's 4, and then there's 7 more. So this is like 1.75 is actually. So that's bigger than 1, so it's growth. Okay, let's keep going. The next practice set, you're going to be graphing things. So here's some stuff to think about. You need to pay attention to the scales, because I'm going to have you do 0 and 1, and they're not going to give you 1 here. So I keep getting it wrong because the second value that I can calculate is when x is equal to 1, and I'm always like follow what they've done. They're going to talk about an asymptote line. Just don't worry about that. It's going to be this line, green line that goes here. Maybe I can, kind of looks like this down at the bottom. Don't worry about that. You never have to move it for this one. There's no translations. So in Algebra 3-4 and even geometry, you'll talk about shifting things left or right and up and down. And there's no shifts that are happening here. And the more formal word is translation. So we're not translating anything. So those two can both stay at 0. Don't move this flat line. Okay, but you do have to take your cursor or your mouse or your finger, I think if there's a touch screen. And how I'm going to teach this to you is just find 0 and 1. So I'm going to say x, and if we want to get really fancy, g of x. And when x is 0, and when x is 1. So let's plug these in. So 2, 3. So have some scratch paper when you're doing this, or have a calculator. So I'm going to plug in 1. Anything to the power of 1 is itself. So that's 6. Oh, sorry, I didn't do 0 first. So 1 is 6. Let's do 0. Anything to the power of 0 is 1. Again, order of operations, we've got to do the exponent before we do the multiplication. So I had to take care of this, but the 2 remained. You have to do exponents before multiplication. Those are the rules of PEMDAS. And it's, again, like B is our y-intercept, right? So it should be at B because the equation is also telling me that that's the initial value when x is 0, or the y-intercept. So at 0, I'm gonna go to 2. And at 1, so this says 2. Don't do it to 2 like Miss Taylor has been doing it when she's been doing her Khan Academy. So at 1, you're gonna have to like move the mouse over, and I think it's pretty easy to drag. You go up to 1. So I don't even care about this 2. As long as I have these 2 lined up, I'm not gonna worry about the rest of it, and you're just gonna click check or whatever. Okay, let's do this one down here. So, ooh, we get a fraction and we get so nervous. Don't get nervous. So my initial value should be 8, and this is less than 1. 3/4 is less than 1, so I know it's going to decrease, or it's exponential decay. So let's plug in 0. And you should not need to plug in 0, ladies and gentlemen. You know what that is. So anything to the power of 0, we have to do exponents first. That would be 1. So that's 8. So in our lovely graph, let's do x and h of x. If our input is 0, our output is 8. And then Miss Taylor only tells me I have to do one more, so just do one more. So 8 times 3/4 to the power of 1. Got to do that first. Anything to the power of 1 is itself. Oh, now we have to multiply with an equation. Oh, with a fraction, so scary. Well, I think you can do it on the Khan calculator, and if you have a calculator, you can do it. But remember, 8 is really 8 over 1, 3/4, and multiplying with fractions is the easiest thing to do with fractions. You just multiply straight across. 24. 8 times 3 is 24. 1 times 4 is 4. So I think... well, you can just put that, so a couple things. If you have your calculator, you don't need a graphing calculator. You can use an app on your phone. You can use the app that's usually already installed. So if you do 24 divided by 4, remember, this fraction is really a division sign, and I get 6. So at 1, I get 6. So again, don't do the 2. At 1, you get 6. And if you do these 2 dots, it does not, it like kind of works it out itself for the rest of the function. You could keep going. There's, you know, you could do this if you have a graphing calculator, or if you've downloaded one, you can always, you know, just put it in, you know, to the power of 1. Try it by hand and then double check it. You could do to the power of 2 divided by 4 to the power of 2. Okay, so you can do this also a lot faster in your, if you have a calculator that works. All right, and the last one that's due Wednesday is about writing functions. So these 3, hopefully if you do this one, you'll see at least one of these. And you don't, when you're doing your own notes, I would not copy all of this down. If you want to, of course you can, but I would just write down important details. So the lion population drops, ding, 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 by 5% every year. Currently, the size is 200. Oh, currently, so my B value, okay, and my rate, I'm gonna say my rate is negative 5%. So when I do this, there's a couple different ways. So I'm gonna say, that says P of T. I'm just gonna do Y, it's okay. So remember, you've got B times M to the power of O. Ladies and gentlemen, I would get this wrong too. Remember, they don't use X, they use T, because that's pretty sciencey, because it, you know, for real world context, it's a lot of times that X value, or that independent variable, is time, some form of time. Okay, so we've got our initial value, and it drops. So remember, we're taking 100% of it and we're losing 5%, but that's as a percent. So we have to say, what's 5 divided by 100? And if we put that into our calculator, the calculator is going to say 0.05. 0.05 to the power of t. Do not put x, put t. So Khan Academy will accept that answer. It'll accept, you know, if they lose 5%, then 95% remains. And if you put that into your calculator, you would get that answer. You could put it as a fraction. They'll take a fraction. That's, I think that's 19 over 20. So they'll do that. They'll help you out there. Okay. Einsteinium 253 is an element that loses 2/3 of its mass every month. So they go down. So let's see, the rate is -2/3. A sample of it has 450 grams. So initial value is 450. Okay, so y equals my b, starting value, and then we take 100% of that, and we're gonna lose 2/3 of the mass every month to the power of t, because it tells me t, so I have to use that. They'll count it wrong if you use x. So you can put that exactly into Khan Academy like that. You don't even have to get fancy with like the fraction thing. They'll do the fraction one for you. So it's nice that they accept and they understand a lot of different answers. Last one. Nana has a water purifier that filters 1/3 of the contaminants each hour. So each hour it's going to lose 1/3 of the contaminants. She used it to purify water that had this many contaminants. So it started with that much. Oh, so that's my b. All right. So y equals my b 1 minus 1/3 to the power of t, because t is in time or hours. Or you could say 1/2 times 2/3 to the power of t. So those are all your examples.